Can you hear me? Yeah, okay, great. I can hear myself. Perfect. Okay. So, hi everyone. My name is Colette Biervliet-Schranz, and I work on Team POW. I'm a young professional / junior software engineer, so be easy on me, guys. And I don't know if you can tell, but I'm from New York, and I came here in January. So if you have any questions about New York, feel free to ask. And today I'll be talking about making Postgres great again, why we ditched Elasticsearch in favor of a Postgres solution. So before I continue, I'd like to clear up some misconceptions that you might have gotten due to the title of the talk. So unfortunately for you guys today, this isn't going to be another Donald Trump themed talk. And you probably were like, oh yeah, make Postgres great again. The American girl's going to talk about it. It's going to be full of Donald Trump jokes, but I do an awful Donald Trump impression, so I'm going to leave that out for today. And the second thing that I also want to clarify is that we didn't abandon or ditch Elasticsearch in favor of Postgres. It's more that we determined that a Postgres solution would be sufficient for the search that we are trying to do. So, yeah, I'm sorry. Instead, I have a revised title for my talk, which is Postgres Good Enough? So it's maybe not as inspiring as the first title was, but it probably conveys the message that I'm going to try to get across today a little bit more accurately. Okay, next up, our agenda. So, now that I have probably destroyed all the trust that you guys have in me, here's an honest overview of what I'll be talking about today. So first I'll go into a brief introduction on our team situation and our decision-making process. Then I'll explain our Postgres research and results. And finally, I'll address the drawbacks of our solution and how far we expect Postgres to take us. So what I hope that you guys get from this presentation is that you might consider Postgres for your searching needs instead of Elasticsearch. And what I hope that you guys, or rather what I hope to get from you guys at the end of this presentation, is for you all to confirm that we ultimately made the right decision. So let's dive into a little bit of background about our team and provide some context on the problem we were looking at. So for those who don't know, we work on the seller dashboard, aka SDD, which is how many of our Plaza sellers can keep track of their orders. So my team, Team POW, is particularly concerned with the open and sent orders page. So to give you a sense of how the partners use SDD, here you can see an open orders page. You can see the seller can see which items from their inventory have been purchased and need to be shipped. And on the right here, there's this cool thing here. On the right here, the seller can handle their order. They have all those options on the side. Now, in order to display all this order information, SDD interacts with the warehouse order aggregator, which is a service under our OPEX. WOA itself aggregates data about orders from several other services to ultimately display comprehensive order information. And while I'm up here and have everyone's attention, I would like to start calling this WOA instead of WOA, because that's actually what it says. W-H-O-A. Whoa. Okay, so anyway, back to the topic. This year, one of our epics was about renewing and revamping these order pages. And one of the larger features due for a makeover was the search. So as you might have noticed in the upper right-hand corner, sellers currently have the ability to search by order number. The seller dashboard searches through all the seller's orders and shipments to retrieve the ones that match the query. So this kind of search is easy enough to do, considering that we're only searching one field for an exact match. Okay, so here you'll see how the search result actually shows up within SDD. It's quite simple, and you only have one match. You're not really likely to have very, very many matches since you're only searching on order number. Okay, now Contrast this with the image of what we're working towards. So in the new vision, users would be able to do a text search that returned partial matches, and then they'd also be able to search and filter on those results. So I guess you could say it was a little bit of an upgrade from the old pages. So this screenshot actually represents the most aspirational functionality of the search. So you see the term theft right there. The term theft should return Grand Theft Auto among other items, even though theft only matches a term in the middle of the product title. So we're searching on a string of text and returning a partial match from the middle of the string. Okay. Now, the other kinds of searching, filtering, and sorting we wanted were not quite as daunting as what you see here. So if we look at a comprehensive list of what we wanted to be able to search on, you see fields such as Yawn or shipping ID. We sort of had the sense that they'd be easy enough to search on given that people are usually, English is my first language, given that people are usually searching on an exact match. So none of this was too concerning. But in addition to searching, we also wanted to have these filtering options. This is the quick summary of what we wanted to filter on. And you see we just have basically like a bunch of date fields, and status, delivery method. And this last delivery method was one way that we were already filtering on. And then we also have our sorting options here, which are all dates. Now, we hypothesized that most of these searches would be fairly straightforward, except for the text searches. But as you've seen, the text searches were pretty much limited to product title and seller reference. Seller reference is just a memo that the seller might add to their order in order to remind themselves something particular about the order. So these other kinds of sorting and filtering things we sort of already had the sense would not be too challenging, but we had to do some research. So, next question to answer was, who exactly was searching? Who exactly is searching? So, we said that a small seller has about 10 orders a year, a medium seller has 500 orders per year, and a large seller has 10,000 orders per year. So we could say that the small and medium sellers, those with 10 and 500 orders per year, they would definitely be using STD and also probably the search in STD. And then the sellers with 10,000 orders or more, they might be using STD, but they also have the option to use our seller API. So that sort of got us to the idea that the average user using our search would have about 1,000 orders per year. And since we're expected to provide data from 7 years in the past, the average STD user would be searching through about 7,000 orders at any given moment. Okay. So now, you've seen that this searching was sort of a big upgrade from what we had before. So also given the fact that the number of orders we could expect in the future was going to only grow, we knew that our old method of searching wasn't going to be sufficient. So if we're going to have cross-domain searching, sorting, and filtering, we needed a more robust solution than what we have had. So it made sense that our first instinct was to explore whether Elasticsearch would be an appropriate technology to use here. So for those of you who might not be as familiar, Elasticsearch is a search index that allows you to retrieve matches, including partial text matches and similar text matches, very quickly. So precisely the kind of search that we are most concerned about, Elasticsearch is able to do quite well. So we're also swept up a little bit in like the glow and trendiness of Elasticsearch, given that's been adopted by big companies and it's gaining traction here at Bol.com. So it seemed like one of those technologies that we would ultimately be adopting anyway. So keep in mind, we're also a little bit concerned about the ability of our search to perform. So It made sense we were turning initially to this well-regarded technology. But the question for us sort of became, well, are we trying to sort of, kill a fly with a bulldozer? Is it too much for what we really ultimately need it for? So, as you also might know, that despite the buzz around Elasticsearch, it also came with a couple challenges. So first, no one on our team had experience with Elasticsearch, and there would be the learning curve of setting things up properly. Second, an Elasticsearch cluster would require some maintenance on our end and resources on our team's end, which was not necessarily a cost we were looking to incur, which I think many people here can empathize with. And the last and most important reason we wanted to look at Postgres was that since Elasticsearch is not a reliable primary data store, we still need some kind of database for Elasticsearch to use. So the last reason is why we ultimately decided that we would research the limits of the search of the Postgres database to determine whether it was going to be good enough for our needs. Since we're going to need a database anyway, why not see if we could forego all the extra costs of Elasticsearch while still getting all the business value that we needed? So to answer this question, we'll move into the second part of the presentation, which is the Postgres research and results. So the title of the talk is probably a little bit of a spoiler in itself, so you can probably guess where we landed on the question. But I'll just explain how we got to our answer, and then hopefully you can interpret the results and tell us whether we made the right decision. Okay, we determined that this was our test data set. It made sense to search through 50 million orders in total, and of those 50 million orders, we had 50,000 open orders, 5 million LVB orders, 45 million LVR orders. The important thing to keep in mind here, exactly how we broke down the data, not really that important. We just had a pretty fair distribution between all the fields that we wanted to search, sort, and filter on. We spread these 50 million orders over 2,000 sellers and picked product details from a table of 10,000 products. So each seller then had around 25,000 orders, which, if you remember from the estimates earlier, was much higher than the 7,000 orders we said that the average SDD user would be searching and filtering through at any given moment. Now, we wanted to keep our tests simple and optimize only if necessary, as you can probably tell by the fact that our first instinct was to forgo Elasticsearch. So we set up a table with order data in a very straightforward manner, so you could see here. We didn't bother with setting up multiple complex tables because, once again, we're trying to just see what the bare minimum was that we could get away with. And after filling the database, we put some indexes on the combination of seller ID and the fields that we were going to be searching and filtering on. So this included order ID, product title, Yawn, seller reference. You saw those all before. So then we used PG Bench tools to run some performance tests for retrieving the information. The business requirement was that we wanted the search in SDD to respond within 3 seconds. So remember that 3-second response also includes the call to other services in order to enrich the information on the matches. So for example, to provide transporter information where necessary. Therefore, we determined that the upper limit of the database response time should be 1 second. And so now, I think you can all say that we're probably at the point of the presentation you came for, the results. Okay. Ta-da. Okay, you're going to have to wait a little bit longer for the results, because before I do the grand reveal, I want to make sure I have your attention for these numbers. So we've got 13 requests per second and 26 requests per second. This became important later on once we made our evaluations. So now, the results for real. Okay, so this is a summary of the tests we performed and the response times that we were getting. It's not totally readable, but you don't have to worry too much about all of this. This is just so you get a sense of all the kinds of tests that we ran. Okay, hopefully this is a more readable table. And we can go over each of the tests, which were all under 1 second. So latency on the left, the amount of time it took to get a response from the database, and TPS on the right, which is transactions per second. So how many complete transactions we're able to make in 1 second. And this was also a very useful metric when we're trying to get responses within a second. Okay, so let's look at Yawn. Great. I don't know. It's interesting. Great. Yawn, as we expected, quite quick. 17 milliseconds. I don't know. Wow, that was not planned. I hope it stops doing that. So this was quite quick, 17 milliseconds. So Yawn can include text as well as characters, but we're only retrieving exact full text matches. So we were pretty confident from the beginning that this was going to be quick anyway. Shipments were retrieved. Here we go. Shipments were retrieved, paginated, in batches of 25 in 27 milliseconds. And now here, I actually want to spend an extra minute on sharing a side note about this that I kept in this presentation against the recommendation of a few people that I practiced my presentation on. So you'll notice here that I added this part, shipments after adding index on order date ascending. So at first, we only had an index on order date in general, which made sense since we were retrieving the pages of shipments ordered by the order date. However, we noticed that we were getting the retrievals pretty slowly. At first, it was 891 milliseconds with 20 connections. So that was a little borderline. But then we added the index on order date ascending, which was exactly how we were retrieving our orders or our shipments. And we saw it go down to 27 milliseconds. So that's 891 milliseconds to 27 milliseconds just by fine-tuning the index on this database. So that, for me at least, showed me how powerful a well-thought-out index could be, and that there was a lot of room within the database, within the Postgres database, to optimize our searches. So we were still able to get probably more searching power out of it, even than you see here. So now, moving on from that little tidbit, which I am glad I kept in. Retrieving all open orders took 40 milliseconds, but each seller had around 25 open orders, so it wasn't that strange that this was still happening quite quickly. So for filtering, as an example for filtering, you can see here, this is like if you were to filter on a shipping date range, and that was also very acceptable, 61 milliseconds. So far, so good. But now we get to the two search options that we were concerned about. So you can see from the last row of the table, we've got the product title start match. So for example, searching Grand and retrieving Grand Theft Auto and Grand Hotel. That returned results in 801 milliseconds. So yes, search on a string was quite slow here, and a search query with a word in the product title, which is that last one down there, was even slower at 861 milliseconds. Now, this was slower, but I just want to emphasize that it was still within the 1 second response time we were looking for, and we were still getting really nice numbers for everything else. Now, does anyone remember the numbers that I asked you to keep in mind a few slides ago? 13 and 26, yes, excellent, great. So 13 requests per second is the maximum number of requests, received last month. If the season absolute maximum then is, let's say, twice that, so 26 requests per second, and each of those sellers was doing a partial text search, the product title matches would still come up at just around a second. So given that we also now have no data on how much this kind of text search even be used since it's not yet available. It simply didn't make sense to focus on the two areas in which Postgres might be borderline at the absolute maximum during the season if everyone decided to search on a term in the product title. And also, if you look at the transactions per second when there are 40 connections, you see for the other kinds of searches, we're still retrieving the information very quickly. So in the end, though we might one day have the need for 40 connections as the number of sellers grows, the kind of load we're realistically seeing nowadays would still allow for quick response times. Keep in mind, too, that for our performance test, we're giving each seller a much larger number of orders than they would realistically have. So we decided that Postgres was definitely good enough for our expanded searching needs, at least at the moment. Scribble that out. So to answer the question I posited at the beginning, is Postgres good enough? The short answer is, with an average response time of 141 milliseconds, I guess, yes. So remember, this average includes the slow response times from the text searches, which have some space for optimization, but which will always be slower than other kinds of searching. So now, finally, how far do we expect Postgres to take us? So the beauty of using the Postgres database at this point is that we can easily add an Elasticsearch cluster at the point it becomes necessary. And when that happens, we can add this on top of the Postgres database and be able to accommodate heavier searching. At that point, though, we'll probably have a better idea of how our users are using search and what kind of queries we'll need to optimize. And if growth continues as projected, the Postgres search should hold up for a year or two. At that point, you can join me for my future presentation, making Elasticsearch great again. So that's about it. But as a last word, I'd like to enthusiastically thank these people who made it all possible. Yawn, our team software architect, and two more senior engineers on my team, Andre and Eduardo, without whom I probably wouldn't be standing here. Okay, so thanks.
Two minutes for questions.
Would you be so kind to scroll up to results page 1? That's not a question.
Oh, next question, please.
Yeah, just say no. I'm a bit puzzled about the difference between product title start match and the next one, because the first one I would expect it to be solved by using the index, and the next one probably does a full table scan. So I would expect the first one to be much faster here.
Well, that's probably a good tip, in which case I think we'll look at the numbers again.
Okay.
That sounds like a good way to optimize our Postgres search, so might not even need the Elasticsearch cluster.
The tip was to add a full text index, I guess, for those listening at home. Yeah.
Hi. I know that your preference goes to Postgres because of the team supporting it. But you also said that you consider Elasticsearch not as a primary data source. Why?
I don't know. I was under the impression that it's quite unreliable.
Yeah, you could look into that as well for the future. I mean, if you eventually want to shift to Elasticsearch, and I'll be happy to have a chat with you afterwards.
Sounds good.
All right, that's it. Thank you very much.